Hi there. This is a tutorial for Lab 3 in Algebra 2, page 84 and 85. So you're going to want to get your book and your calculator out because this lab is about how to use your calculator to find various important points on a graph. We're going to do some simple ones like lines. We're going to do some more complicated ones like parabolas in order to demonstrate what buttons that you want to push in order to find the data that you want. Hopefully you have a TI-84 plus CE. That's what I'm using today, and that'll help you best to find the things that you need to as we go along. So hopefully now you're looking at page 84, 85. If not, hit pause and go find that. But we've got a few important points that we want to find. We're gonna go after finding y values given an x value. That is like a function. We're going to plug in something for x, and we're going to see what kind of answer that we get out from there. So we want to use our calculators to find the y value given a particular value for x. Second, we're going to be looking for roots. Roots are also known as either x-intercepts, or they're also called the zeros of a function. So we'll be using our calculators to find roots. Thirdly, we're going to find minimum or maximum values on a graph. We'll be using quadratics for that, but you can use any kind of graph to find the lowest value or the highest value between 2 points. And then we'll finish up by graphing two equations at the same time and finding the one point where those two graphs intersect. So those are our goals today. Find y values, roots, x-intercept, zeros, minimums or maximums, and intersections. Okay. So if we got a graph of, let's say, a parabola that's over here, you can see that there's quite a few important points that we might be interested in finding. We might be interested in where it crosses the y-axis, which is the line at x equals 0. Sometimes that's actually where the problem starts. Like if we're doing some equation in physics that involves time, we're not going to go into negative time. We're going to start at 0, so we might want that. Also, we've got the two places where this graph crosses the x-axis. Those are the zeros, because this is the line y equals 0. We want to know when we plug in x into a formula when 0 comes out. We also might want to know the lowest point, and here this would be a minimum at the bottom of the parabola. Or we might want to know any point on this graph and figure out what that is. What is its value? If I plug in x, what do I get for y? So with parabolas, there's lots of information there that we want. We're going to start, though, with just a line. So I'm going to turn the calculator on and go to the y equals. And the first equation that the book is asking us to play around with is 2x minus 4. 2x minus 4. Now I'm going to zoom and change my window to decimal. That's the fourth one. And it gives me a nice even grid and draws the line in there. We're going to be using the trace button and the one right above it in blue, calculate, quite a bit here. First of all, push the trace button. We see there's the cursor on the graph. And as we scroll using the left and right arrows, we see the cursor move and the values for x and y. You can see them at the bottom of the screen. So right now I'm at where x is 1.5, y is -1. Nice thing about the trace function is if the intervals of going across aren't good, like that one's actually pretty good, I can just type in whatever number I want for x and see what that turns into on the y-axis. So if I want to know when x is 1, I can just type in 1 and you see x equals 1. I hit enter and it puts the cursor right there and says when x is 1, y is -2. Okay, so that's one way we can search for a particular value. Also, you go second, calculate, and the first thing there on the list of things that it does is value. So it brings up the exact same type of thing. I can say, what's the value of, I don't know, plug in 2. When x is 2, y is 0. So you can use the second trace or calculate function in order to find any value that you want to. Another way you could do this, especially if you're interested in plugging in integers, would be to make a table. And maybe you want to start at 0 and go up by 1s. Okay, and have these both on auto, and then you go second graph, and it pulls up a table, and you can scroll down through the x values and then see what y value goes along with it. If it's not in big enough or small enough intervals, like if you want this to go by 1/2's, you can go and tell your table to go by halves. And when you go to make your table, now it'll go 0 and a half and 1 and 1.5. You can set it to whatever type of intervals that you want it to do. Second, we want to calculate a 0. Go back to our equation, graph. We want a 0. And 0 is going to be, what's that point right there where it crosses the x-axis? Tracing might do it, and it does when you've set it to decimal, but maybe the equation is going to be a little bit more complicated than 2x minus 4. Okay, now why do they call them zeros? The best reason to say here, we had the equation 2x minus 4. We're actually looking for when that equation equals 0. What value for x will make this, this statement true? So you can do it by inspection. You can just think about it and say, well, when x equals 2, we'll have 2 times 2 minus 4, and that equals 0 because 4 minus 4 is 0. So 2 is considered to be a 0. It's what you would plug in for x to make y come out and be 0. It's probably more important when you have a parabola. Let's say we take something like x squared plus 5x minus 6. And maybe we want to start with y equals, but we really care about when y equals 0. That picture, go ahead and type it in. We got, I'll just replace this one, x squared plus 5x minus 6. And we'll get a parabola that crosses the axis in 2 places. It's kind of, you got the glare there. Crosses at 2 places. I want to know where those 2 places are. That means that there's 2 different numbers that if I plug it in for x will make this equation equal 0. So we're concerned with both of those places where y equals 0, and we can solve that in a couple ways. One way that we've done in the past is we factor out stuff. We factor this down. -6 is the product of -1 and a +6, which adds to a +5. So we get this kind of factoring, and if I plugged in the number 1 in for x, I'd get 1 minus 1 is 0, and 1 plus 6 is 7, but 0 times 7 is 0. So that would work. And the other number that would work is if I plugged in a -6 into both of these. -6 minus 1 is -7, but -6 plus 6 is 0. 0 times that equals 0. There would be my 2 solutions. X is 1 or x is -6. You can see that here on the graph, and if you want to just do it with the calculator, you go second, calculate, and we find that number 2 is asking for a 0. But it does come of a funny thing here on our calculators. When we ask it for a 0, let's see if we can get this to focus here for us. Focus. Focus. There we go. It starts by asking for left bound, and so we've got to use our arrows and scroll over just to the left on my graph here. There it is. There's my cursor. Move it a little bit to the left of where I think it's crossing and hit enter. And then ask for right bound. And I'll go a little bit to the right of where it crosses and hit that. You can see at the top it has these arrows and some little lines. So I'm asking the calculator to look between this value for x and that value for x for where the answer is 0. It says guess, and usually they want you to move your cursor close to the intersection point, but you can hit enter and it'll say the 0 is at x is -6. That's when y equals 0. But there's another one over here, so we got to do it again. Second calculate a 0, but this time I'm going to scroll over closer to that other one. Okay, here it comes, negative. Where's my cursor? There it is. Left bound, I'll start over here. Right bound, somewhere over this way. And it guesses and says, well, at 1, 0. When x is 1, then y is 0. There's our other one. So again, that's second calculate, and we would pick, focus, we pick number 2 on the list. And it gave us the same answers as we had there in that problem. Okay, we now want to calculate a minimum or a maximum. And usually these types of problems happen when you have parabolas. I'm going to change the numbers here a little bit. I don't want this to go down so far, so I'm going to only go -2. And hopefully we'll see that, oh, we don't even see the bottom of it. Okay, I'm going to move it up a bit. I'm going to say +5. Let's see if we can see the bottom of the parabola. Yep, there we go. So right down there is a minimum point. I want to know what that minimum point is. I'm going to go second calculate. I'm going to choose number 3. Tell it's a minimum because my thing opens up. So I'm going to scroll over a little bit to the left because it asks for a left bound. I'm going to say let's start looking there, and then let's look between that point and some point over here, because the lowest point's right here between those areas. And say guess and go okay, and it gives me the values at which the lowest point can be found. That's the vertex of the parabola. It's its minimum. Now if I don't give it the right things to look for, it's just going to do whatever I tell it to. So what if I missed and I was like, well, left bound's here, and then how about from here to here? It's going to look for the lowest value between the 2 points I give it, and it's going to go back to the beginning of where I asked and say, well, that's the lowest point of what you gave me to look for. So you need to make sure that you move it to the left of that lowest point and to the right of the lowest point, and then ask it what the lowest point is. If that parabola opens the other direction, if it opens down and has a highest point, let me type one in here that will look better on the graph. Let's go with -5. See if we get a highest point. There we go. Then we're going to look for a maximum. And that would be second calculate. We'll go down to number 4. It's looking for the biggest value between 2 points that you want to give it. So I'm going to pick from between here and here, for instance. And there it is. There's our maximum point at about 2.5. And y is 1.25. And we just write that down. Just ask it for the minimum or the maximum. That's a pretty important point on a parabola. If this was physics, we'd have something like this, and we would care about the highest point in the path of a projectile. What's left? Minimum, maximum. Oh, calculating intersections. Okay, intersections happen when you have two equations, and you want to know what point they share with each other. So I'm going to go 5x minus 2, and we'll go with negative 3x plus 2. So I'll get 2 lines here. Line number 1 and line number 2. So I can see that they crisscross right there, but it's really hard for me to tell exactly where that is. Okay, I want to know the one point that both of these equations share. I'm going to go second calculate. I'm sorry, that's blurry. Let's get that. Focus on this. Focus on this. Focus. There we go. We're going to ask it for number 5, intersection. And you can see here that at the top of the screen and at the bottom, you got things in blue because the cursor's on the blue line. All it needs to know is what 2 lines to look at. And so say I hit enter, and then you see that the cursor jumps to the red line and everything's in red, and we want that one too. And then it finds the exact point where they crisscross. They both share the point 0.5 and 0.5. And why does this matter? Well, what if I had 3 lines in here, right? What if I had x in there as well? Now I pick something else. I go x plus something or other. X plus 1. I ask for an intersection. Well, which intersection? Is it that one? Or is it where this black line crosses the blue one, or where the black one crosses the red one? So when I go to do that intersection, if there's 3 lines, I have to tell it which 2 to look for. So which intersection do I want? I have to tell it which is the first curve. And I'm going to use my up and down arrows to change which one I'm picking. So maybe I want red and black. Okay, there's red, and it automatically goes to black, but I could switch it over to blue. I'm going to go to black. There's my second curve. That's the intersection right there. And you can switch it so that it is choosing 2 equations and then finding which ones where they crisscross. So you're going to do the very same kind of thing but with different equations. On page 85, there's a lesson, some graphing calculator practice A to C, and then you're going to do some review questions from lesson 13. I'd like you to do 9 and 10, 12 to 15, and 19 to 21, and that'll be due on Monday. Okay, don't eat any bad burritos, please, and make sure you drink lots of water. Bye.